All right, so trig identities are basically equations. They're trigonometric equations that set two equal things to one another, right? So they set two things equal to one another. So basically, a trig identity is something where the left and the right are equal to each other. Now, we're going to start off with some that you already know. For example, we have a few identities that are called reciprocal and quotient identities, right? And what's a reciprocal? So if I have 2 over 3, the reciprocal is 3 over 2, right? Now if I have just 2, what's the reciprocal? 1 over 2. So reciprocal is 1 over the original. So take a look at why these are called reciprocal identities. Because sine of theta, we know, is 1 over cosecant of theta, right? And the same way, cosecant of theta is 1 over the sine. And so we know that cosine and secant have the same relationship. Cosine is 1 over secant. And we know that cotangent and tangent have that same relationship, right? Cotangent is 1 over the tangent. So none of this is actually new to you. And so those are the reciprocal identities. Then we've got what we call quotient identities, right? So a quotient identity is that tangent. What is it really? It's sine over cosine, right? So tangent of theta is sine of theta over cosine of theta, and cotangent is cosine over sine. So none of this is new, right? So if you're given, so here's what this means. If you're given sine of theta, then cosecant is the reciprocal. So for example, if sine is 2 over 3, then what's cosecant? 3 over 2. So this we've been doing even last year. I mean, last chapter, right? We've been doing that already. So then, if we're going to apply it to this, if you're given cosine is 3 over 4, and you need to find secant, how much is secant of theta? 4 over 3. All right? Okay, so now look at this one. Secant is 5 over 4. Tangent is 3 over 4. And I want to find sine, right? Okay, well, that's a little bit more complicated. So I have secant. What does secant give me? What's the reciprocal of secant? Cosine. So I know that cosine is cosine of x, 4 over 5, right? So here's cosine, here's tangent, and I need sine. Is there any relationship between those three? Yeah.
Well, tangent is sine over cosine.
Right. So tangent of x is sine of x over cosine of x.
And we have cosine of x.
Right, so we have 3 over 4, that's tangent of x, equals sine of x, which is what we need, times cosine of x, over cosine of x. Right, so that's one way you could do it, and then what would we multiply by? Both sides.
3/4.
Not 5 over 4, but 4 over 5, right? Because all of them are on the bottom.
Wait, wouldn't sine just be 3?
Mm-hmm.
Yeah?
Yeah.
Okay, then why we,
So, it would be 3 over 5. So we're going to multiply by 4 over 5. Those go away. So sine of x is 3 over 5. Okay. All right. Another.
Wait,
So
I'm so sorry. Why aren't we multiplying by 5 over 4?
so you multiply by the whole everything that's in the denominator, right? So let's see what's in the denominator.
Trying to get rid of the denominator.
Right.
We're just trying to. Oh, okay.
Okay. All right, so remember the unit circle. Sine and cosine, if you remember on the unit circle, represent the vertical and horizontal legs, right? So if I've got a triangle here, the vertical is always sine of theta. The horizontal is always cosine of theta, right? And so this is also a right triangle. Is that right? So suppose, for old time's sake, I didn't call that a cosine. I called it x. And I called this one y. Now, is there a Pythagorean theorem happening in there?
Sure.
What would the Pythagorean theorem look like? Right? So basically it would be like y squared plus x squared equals what squared? 1 squared, which is just 1, right? Y squared plus x squared is equal to 1. Okay, but look, in trig though, that y is called what?
Sine of theta.
So sine of theta squared, right? Instead of y squared, I could do sine of theta squared. And cosine of theta squared, instead of x squared, I could do cosine of theta squared. That equals to 1. Is that right?
Yeah.
Okay, now look. I can write sine of theta squared like that, but it's sort of cleaner and more conventional to write it this way. Those two mean the same thing.
And you can plug that in the calculator?
Yes and no. We're not doing that just yet.
It's a no package.
So when we write it that way, take a look at what we have. We've got sine squared theta plus cosine squared theta equals 1. Now, is it true that that this equals 1? It's true, right? Like we just figured that out. So this is one example of a trigonometric identity, a trig identity. Basically, it's a relationship where the left and right equal to each other. Now, what theorem did we start with to get this? Pythagorean theorem. So that's why this identity is called the Pythagorean identity.
Sine squared theta plus squared theta equals 1 is Pythagorean identity.
Yep. All right, and that's something that everybody just knows. So that's one of those things where, like, if somebody taps you on the shoulder and says, hey, what's the Pythagorean identity? You just go, oh, sine squared theta plus cosine squared theta equals 1. Okay? We love that identity so much that you know what we're going to do to it? We're going to have a little fun with it. So here, I'm going to write it here, sine squared theta plus cosine squared theta equals 1. And you know what? Just for fun, right? Just for fun, I'm going to divide everything here by cosine squared theta. Why? Because I can.
Oh, and then you would get your reciprocal.
I can as long as I divide everything by it. So now let's see what we get. What was sine over cosine? Tangent. So sine squared over cosine squared, tangent squared. Sine cubed over cosine cubed, tangent cubed. Okay, so then this will be tangent squared theta plus, what's cosine squared over cosine squared? 1 equals, what's 1 over cosine squared?
1 over cosine squared. Or cosecant squared.
Not cosecant.
Oh, secant squared.
Secant squared theta.
Oh, that's what so much.
Oh my God, look. I have another
Identity.
Pythagorean identity. Look, it's here. I have another Pythagorean identity.
Those are kind of like formulas.
Yep.
They're the same
Yep.
thing, though.
Exactly. So now take a look. That was so much fun. I'm gonna.
Do it with sine now.
That was so much fun. I'm gonna do it with sine now because why not? So let's divide everything by sine squared theta. All right. What's sine over sine?
1.
1. What's cosine over sine?
Cotangent squared.
Cotangent squared theta for this one equals, what's 1 over sine squared? Cosecant squared theta. Huh? Here I had cosine over sine.
Because it's x over y.
Now look at what I've done. I started with this identity. I divided everything by cosine squared and I got this identity. Then I divided everything by sine squared and I got that identity. These three are buddies. These three are the three Pythagorean identities, and we can use them to find ourselves mighty good stuff. All right, so now, so cosine of theta I'm given is 1 over 3. I'm given tangent of theta is less than 0. And I need to find sine of theta and tangent of theta. So I'm given this piece of information. I'm given this piece of information. I need to find, and I need to find sine and tangent. Okay. So step 1, use the information on the sign of the functions to determine the quadrant. One piece of information tells me cosine of theta is 1 over 3. Now, believe it or not, there is an important piece of information there that we just glossed over. And that cosine of theta is positive 1 over 3, right? This is positive. Now, in which two quadrants is cosine allowed to be positive? Here and here, first and fourth. Another piece of information is tangent of theta is less than 0. What does less than 0 mean? What numbers are less than 0? The negative. So less than 0 means negative. In which two quadrants is tangent negative?
Any of them.
All of them except that one.
It could be all of them. Quadrant 2, 3, 4.
Tangent is negative here?
Yeah.
Yeah. Is tangent negative here?
Yeah.
Oh, no, just those two.
No, but it's negative here,
Yeah.
right?
They're not-
Because those two are negative, and negative is positive.
Everything is positive here. All are positive there. And tangent, student take, so tangent is positive here. That means it's negative there. Now, in which two quadrants do both of them match up? In which quadrant do both of them match up? There's just one quadrant where both of them. Quadrant 1? Both of them match up in quadrant 1?
Quadrant 4.
Quadrant 4.
4.
Quadrant 4.
Meaning that they're opposites.
Well, no, it's just that these two conditions are met only in this quadrant.
Okay.
Only in this quadrant are both conditions equally met. Okay? So, both conditions met in quadrant 4. Okay? So that's the first part, is figure out the quadrant. Now, number 2 is we need to find the trig identity that relates the quantities we have with what we need to find. Okay? I have cosine. I need to find sine and tangent. Is there an identity anywhere here that relates cosine to sine or cosine to tangent with no other unknown? Anything here that relates cosine to sine?
Yeah.
Which one?
It's oh wait, never mind. It's the second one.
So nothing here, cosine to sine. Here there's tangent too, which I don't have tangent either, so that's not going to work. You can't have two unknowns in an equation. So none of those. Is there anything here that relates sine and cosine with no other unknowns?
The first one.
The first one. So I'm going to use the first one.
I thought it's sine and tangent.
Well, I need to find two things. I need to find sine and tangent. So I'm going to relate cosine to sine first, find sine, then find tangent. So sine squared theta plus cosine squared theta is equal to 1. Now, what do I have here? I have cosine theta, right? So sine squared theta plus, look, this is cosine squared theta. What's cosine of theta here in this problem?
A third.
1 over 3, but this is cosine squared. Squared equals 1. Okay?
So that's just so.
Okay, so now,
Square should be 1.
yeah, so sine squared theta plus, how do I square the 1 over 3? Who does that 2 belong to? Both of them. So it's 1 over 9 equals 1. So now, how can I get rid of the 1 over 9?
Multiply 9.
You subtract 1 over 9.
Okay, you just multiply. So you get 8 over 9.
Well, it's sine squared plus 1 over 9, so I would have to subtract. So sine squared theta is 1 minus 1 over 9, 8 over 9.
Then you divide by sine.
Well, we can't divide by sine. This is sine squared theta. How do I get rid of the... Take a square root. Take a square root. Okay.
Does that come out to an actual thing?
Okay, so sine of theta is equal to how much now?
2 root 3. No, wouldn't it be 2?
Okay, so it's going to be the square root of 8 over 9. But if we take a square root of both sides, what do we get here? Plus or minus. Plus or minus. Right? Because if you square both sides, you get plus or minus. So now, sine of theta is plus or minus. Now the square root belongs to both. So on top I have root 8, which is 2 root 2. On the bottom I have root 9, which is 3. Okay, but now, what's the deal with plus or minus? I need to get rid of the plus or minus. Huh? Okay, you remember here we said that our answer was in quadrant 4?
Yeah.
In quadrant 4, is sign positive or negative? Negative. So, I say
It's negative
in quadrant 4, right, sign is negative. So I'm going to take sine of theta to be negative 2 root 2 over 3. Okay? So this told me there are 2 possibilities for sine, positive or negative. But I just found out that there are sine is negative in the 4th quadrant.
because tangent.
So I just take the negative. Okay?
And that's because tangent can only be negative.
No.
Right? That's why sine or negative 2 root 2 over 3 is your answer. Because sine can't be positive.
Right.
Okay.
Okay, so am I done with this problem? I found sine. Now I need to find tangent. Right? So how do I find tangent?
Sine to tangent.
I have
It's sine.
sine of theta and I have cosine of theta. Now I need,
Oh, it's tangent over sine. Sine over cosine.
right, I need tangent of theta. So tangent of theta is sine over cosine. Okay, so now take a look. This is sine of theta. Okay, you can divide by cosine or you can multiply by the reciprocal of cosine, right?
1 over cosecant.
So 3 over 1.
Oh, so the 3 just can't go out.
Okay? So now these go. Okay, so let's do that again. Let's do that again. This is sine of theta, which was negative 2 root 2 over 3, over cosine of theta was how much? 1 over 3. So now the 3's go away. On top I have negative 2 root 2, so that's the answer.
So once you find the first one and the second one.
Cotangent of theta equal to 2. cosine is less than 0. All right? So let's go with step 1. Step 1, we have to use this information to find the quadrant. All right? So step 1, find the quadrant. Okay. What pieces of information do I have? I have that cotangent is positive 2. In which two quadrants is cotangent positive? Is cotangent positive in quadrant 1?
Yes.
Is cotangent positive in quadrant 2?
Yeah. Is it split? No, it's third quadrant.
It's third quadrant.
Just
Okay.
because it's split
All
doesn't mean
students
it's
take calculus, so take tangent.
Oh crap! You're right.
Okay, I'm sorry.
No, I'm so sorry. No.
Okay. Second condition is cosine of theta is less than 0, so it's negative. So in which two quadrants is cosine negative?
Second
Second is
Third.
cosine negative in second.
and third.
Is that right?
Yeah, all students take
Second and third. So in which quadrant are both conditions satisfied?
three.
Bottom left, the third one. So the answer is in quadrant 3. So any answer I find, it has to like be in the satisfied quadrant 3 situations. Okay, I have cotangent. I need sine and cosine. So go and search for an identity that connects cotangent to sine.